Hello, my name is Luis Javier Salcedo, and this is my final project for forecasting the air revenue for passenger miles. The business background is that the air revenue passenger miles is one of the main and most important KPI used by airplanes to measure supply and demand. Airlines and air cargos can observe the total miles um, traveled by the customers or merchandise and is used to forecast revenue control cost and control their logistics. For example, during COVID-19, the air traffic had major disruption of activities. Therefore, forecasts on this subject helped to make strategies, routes, and schedules and have more control over capacity management. The problem and objective that I had is that the problem aims to forecast the air travel demand for the next 24 months and use historic data from FRED database and air revenue passenger miles. The analysts will help to accurately forecast the scheduled demand for airlines and cargo services, but also will increase the supply chain optimization. Um, Therefore, will reduce the uncertainty of forecasting demand after COVID-19 with the use of advanced predictive methods. The data. The information comes from freight database from Air R PMTSI. The database contains two columns from observations date in month basis from the 2000 and 2025 that contains the revenue passenger miles in thousands of miles and are not seasonally adjusted. The data was transformed and checked using the ADF test, which helped to adapt in the case that the database was not stationary. Also, where drop the missing values and patterns. Forecasting methods. The methods that I used is seasonal NABID method, which repeats the value from the previous year to forecast the next 24 months. The halt winter season method that extends and smooths the regression by adding trends and seasonality. Auto-regression model, which uses lags in previous observations to forecast. The SARIMA model, which captures the ARIMA and seasonal patterns to forecast. The results that I got is that the first one provided a forecast benchmark, but lacked seasonal and trends capture. The Holt Winters was the best accuracy overall due to the map and effectivity model, the trend and seasonality of the air miles. The autoregression was underperformed with high error metrics in the map and fails to capture seasonality and trend. And the Serima slightly underhold winters. This method performed well to capture seasonal and non-seasonal patterns. This is the forecast versus the actual one, so that you can see some of the difference. This is my Holt Winters Sarima forecast model. This is the forecast, the Holt winter forecast from May 2025 and estimated for April 2027. In my conclusion, Holt winter seasonal methods demonstrated the best overall performance with the lowest map and stable residuals, which helped to fit historical data Moreover, capture the trend and seasonality, making it suitable for the air travel demand forecast. Nevertheless, the method can include base when assuming that COVID-19 in 2020 as a seasonal pattern. Based on the results, I went to the conclusion that it's recommended to use this method as final approach for planning of the future in air travel demand, as it remains stable and show fluctuation between 85 and 105 million miles per month, which suggests a steady recovered and stabilization for COVID-19. This is the appendix. So this is my accuracy comparisons that I did, the screenshot, and just the graphics of the residuals that I got.